Hi everybody. You know, there's a lot of room here. I mean, you don't have to crowd yourself like that. I will start first with a couple of questions. How many of you have IoT devices at home? Not bad. How many of you have received those devices as a gift, as a present from someone else? Nice. How many of you have researched the security of those devices before installing them in their home? Nice. Okay. Basically, today we'll talk about what we did with an IoT device. But first of all, some things about me. Wait a minute, this is not me. What happened? There, fixed. This presentation is usually given by a colleague of ours, Jay. He's the one that actually made the research and stuff like that. Unfortunately, Jay is unavailable for the moment. He's feeling visible somewhere in the United States. And after a few years, he persuaded me to do this presentation. Now, as a bet with him, I told him that I would get more applauses than he usually does. But unfortunately, this is my first presentation in like 4 years. So in order to get those applauses, whenever you see me freezing or stuttering or stuff like that, please clap your hands to give me some more courage, okay? Thank you. There you go. Funny note, before we head into the presentation, Jay actually rented a car back in the US like 6 months ago, and the car had connectivity with an iPhone or whatever to play music and whatnot. And since it was unregistered, he registered the car on his name and entered his details, and everything went well. The funny story is that even 6 months later, he still gets emails with the update status of the rental car. I mean, he got it only for 3 days or something like that. But nobody from the rental service unregistered the car or did anything. So he gets monthly emails with the mileage and consumption and whatnot. Yeah. IoT, smart devices, smart things, smart everything, smart outlets, smart fish finders, smart, everything is smart, but smart has several meanings, okay? And we'll talk a little bit about power outlets today, but basically all the devices that you see here are devices that we found vulnerabilities for, except the fish finder. I don't know why it's there. For me as a parent, the most interesting one is the smart Barbie doll, where hackers, it's a smart doll that can talk to your kid and teach them maths and geography and stuff like that. And the hackers actually took over the doll and started to talk with the little girl that had the doll, and it was scary. Again, this is Jay. Another smart device he tested once in a conference, and now it's actually being sold, is they call it a digital drug. It's a device that you can put on your head, and with a mobile app, you can tune it to make you feel more energetic if you're mellow, or to calm down if you're more nervous like me right now, and stuff like that. And he actually put it on getting more energetic, and after 15 minutes he passed out and literally dropped to the floor. Now it's funny because I wasn't there unfortunately, but I've been told it's true. Imagine that someone could control this device remotely without your knowledge, okay, and you have it on your head. So I'm trying to say that IoT is scary, if you don't already know. Now, getting back to the most common problems of IoT devices. What makes them unsecure? Not all of them, but some large chunk of them. Default passwords, undocumented default passwords. I mean, you get a device, you don't even know it has a username and password. It may be hidden in the management application like 3 screens away, but you never know about them. This is the coolest selfie that a guy did with his phone controlling the surveillance camera from one cafe, the guy with the smiley face. Weak or no encryption. Most devices obviously they're connected devices, they talk to some web service, to some cloud or something, or to some remote application. We've seen a lot of cases with, where there's no encryption or just very weak, very easy to crack. Command injection, again, sanitization, these are like issues we security researchers have seen like 20 years ago on Linuxes and whatnot. Apparently, it's a new wave of unsanitization user input. Again, very old services, very old, I don't know, HTTP services that are embedded in one small device, busy boxes and whatnot. Wi-Fi configuration hotspots. There's actually a smart doorbell, and by smart, it has a camera, and whenever someone rings, it gives you a notification on your phone and shows you the video of who is at the door. Unfortunately, that doorbell only has one button, the one you ring to. But in order to configure it, you have to press the button for 5 seconds. In that moment, it spawns a new Wi-Fi hotspot in order to connect to the application and configure it. Now, what's stopping everybody who comes to my door to press that button for 5 seconds? Okay, so these are things that, again, companies that develop these kind of devices, they don't have such a background or history in software development, security, and stuff like that. Most likely, they don't really see the full picture whenever they implement stuff like this. Another problem, okay, we have a problem, we have a vulnerability, let's update it. Super. Well, it's not that easy, to be honest, and we'll see in a few slides. Now, unfortunately, the demo gods played a trick on me. I was supposed to have a demo with this outlet. I don't know if you can hear, but it kind of broke. So I do have some videos on a demo that Jay did some time ago, but it would have been fun to have it live. I'm sorry about that, but what can we do? So this is the smart outlet. It's sold in like tens of thousands of units. It basically enables you to turn it off and on from your mobile app. You can have schedules for, I don't know, the air conditioning and whatnot. You can have email notifications. That's fun. I mean, the outlet sends an email whenever it turns on and off. That's cool, but we'll see why it's cool. It can be set up via mobile app. Now, the flow. Download the application, plug the plug, obviously. Whenever it's in installation mode, it generates a wireless hotspot for the installation. The application talks to the plug to give them the Wi-Fi Wi-Fi password and whatnot. You can set up the email alerts. That's actually very funny because they didn't want to, I don't know, be categorized as spammers or something like that. They added the option to enter your email account and password, so they would send the email via your SMTP server, not theirs. This is okay, maybe it may be a smart thing to do, making sure you get all the emails and stuff. So, hold on, I'm not joking yet. Okay, so the app sends the installation step. The app sends the Wi-Fi connection and credentials and whatnot, and then the plug starts to check if there's internet connectivity by making the connection to google.com on the HTTP port. After everything is set up, the plug constantly sends UDP packages to their cloud saying, hey, I'm this outlet and I want you to know that I'm alive. If you can send me some commands. I mean, that's the way they keep the UDP tunnel open in order to receive information. The most important field we see here is the ID value. That specific ID value is actually the MAC address of the outlet. On the outlet, there's a setup phase. There's a light HTTP server running in order to communicate with the app and whatnot. And what we saw it was a very interesting thing: the authorization. Basically, there's a string there. It's a base64 encoded string, which basically means admin 1, 2, 3, 4. Okay, remember when we talked about default passwords. This is one. Okay, you do have in the app the support for changing that password, but it's extremely well hidden. I mean, you have to dig it through, and there's no documenting on it or anything. Okay, so getting back on how things work, the app sends a request to the ADMX cloud saying, I need this outlet, which means the ID value, basically the plug with the MAC address of this, and the hash of the username and password, the one that we saw previously. And it says to the cloud, okay, I want this outlet to do this action. Okay? One of the actions that you could do, again, is changing the password. Fine. We'll talk a bit about that later. Now, the power router receives the message from the cloud. It checks the hash, username and password. Do they match? If not, it's dead. You have to restore it. If they do, that's okay. And then they can send the commands. Okay. First thing we try to do is how to turn it off and on again. I mean, we saw that we have all the information that we need to identify a specific plug. So let's try to generate an action. Now, any interaction the app triggers with a plug, the plug sends back a full status. Basically, the whole configuration that it has, it sends back to their cloud. On and off, other actions. Again, the same problem. At the installation time, it should be prompted directly. Please change your username and password. Okay. It's not. So basically, what we did, we reversed a little bit their traffic and saw how to send a command. And basically, we got the ability to turn off all 60 million plugs that could exist in the world, because we only need the MAC address and the default username and password. This is a video from Jay doing the demo in Beijing. He was in Beijing, what we see on the left, and on the right it was a lamp on one of our desks here in Bucharest. If we could play, or should I? Okay. Turning it off, turning it on, there you go, and off again, please. Okay, so that's cool and dandy. I mean, we can, I don't know, turn someone's house into a Christmas tree. That's nice. Getting back to the schedule, turn off actions and the email notifications. Okay, I succeeded to turn off myself or something like that. You have to configure your email address, your password, and the SMTP server to be used. Now, this is the information that the plug actually sends to the cloud, and it's very cryptic and you cannot see anything. However, it's basically some bit flipping. So this is the code that decodes that entire TCP dump that we just saw previously. There you go, the full report. And I don't know if you can see very well, but we have mail sender, mail recipient. We have authorization password for the email. Okay, it's base64 encoded, but still. So basically this outlet sends your email password to their cloud in an unencrypted connection. That's nice. Confirmation. So, what do we have so far? We can sniff and decrypt some sensitive data. I mean, your password is not something that should be openly available. Turn it off and on again. What's next? Who knows what could be better than this? I'll give you a hint. I'll give it a second hint. Oh, come on! Oh, it's boring, I'm sorry. There you go, enthusiasm, that's what I want to see. Okay, command injection. We talked a little bit about one of the flaws in IoTs in general is running commands from received data that you receive from the internet without checking anything. What we did is basically we hijacked a firmware upgrade for this outlet, applied all the steps, bin walk and whatnot, and we disassembled it. And we found this very nice piece of code. You have the ability to set a username and password. Basically set the password, but they don't do any sanitization on the input. So if I have a password like letter A, and then comma, semicolon, and then some Unix command, it will basically run. The problem is that it's limited to 32 bits, but still it will run. What did we do here? Oh, right. So here we just send the change password to command and open the telnet key daemon. But that's okay. I mean, in order to access that plug, you have to be in the user's network. That's not really fun. That's not really useful. So we need to, I don't know, step forward. We need to find a way to execute the connect back shell in 32 chops. It's not rocket science. I mean, everybody can do it. But what you need is basically a two-letter domain. So we did that. We found one sequence that fits. This is it. That specific domain actually doesn't exist anymore. But another problem was that we weren't exactly sure how we can download stuff. It doesn't have wget or curl or utilities like that. Fortunately for us, it does have FTP get. Okay, so just set up a FTP server on that domain and there you have it. This is the simple script. I mean, this is the first entry point. Okay, what we do here is disable the password for the root on the list. Basically, it's a Linux. I mean, okay, we set back the default password for the plug, and then we can download the payload generated in Metasploit in order to get the reverse back shell. Again, video please. So this is a remote server that we have Metasploit who started with the reverse shell payload. This is the password that is going to be set. We have the MAC address of the device. There you go. This is the logs from the FTP server, and we'll see that first it will get the A shell script, hopefully. Oh, come on, demos in videos should not fail. And then it got the execme payload. What we have here, this is a remote shell from, I mean, literally from Beijing, somewhere in Romania. Oh, yeah, right, nice. What we're going to see here is the amount of information that an attacker has access to. You think your Wi-Fi password is safe? Not anymore. I don't know why he did that. So basically, this is a fully fledged Linux, albeit in a small factor. I mean, we don't have a lot of resources, but it can be easily added to any botnet that you want. Thinking writing something else. And, the most troublesome thing is that you don't need that much in order to practice these kind of objects. I mean, you just have to iterate through all the mechanisms. Okay, there may be like 0.5% of people who change their password, but I'm not sure. Okay, so what's the impact? What do you do? How do you protect yourself with this software? Other than unplug it and throw it away, obviously. It gives the attacker full network access. I mean, literally full. He can do. Obviously, it can be added to. But then again, right before one of the demos, we had this alert in the app. I mean, I don't know if why they're asking a question when I don't have the option to say yes or no, but either way, it's good. I mean, come on. Moving back a little, we actually, when we discovered the issue, we informed them, obviously, gave them the, I don't know, I think 30 or 60 days to fix the issue. After more than 60 days anyway, they gave up further. What do we do? How do we do the demo? Well, we have the video, but if we were to do the demo live, how would we do it? Video, please. Okay, so it takes us to a web page where you have the download button, but no way to install the firmware upgrade. I mean, okay, now what? It's a web browser. Anyway, so, yeah, I'm sorry. So, I don't know how to put it. I mean, PCs and, I don't know, smartphones, tablets, stuff like that, they have been developed by companies that do have some history in software development, do have some history in security, do have some history in remediation and stuff like that. But there's a plethora of devices that, I don't know, this outlet is like $20. Nobody's going to invest in a large security program or stuff like that for an outlet that costs $20. So, and the fact that these are, how should I put it, small powered computers, but still computers inherently, that means that usually they run old code, very old code. And it's easier to hack than a PC right now, nowadays. Again, the users of these outlets are a lot less educated than, I don't know, a computer user. And they don't really associate IoT or smart devices or, I don't know, with security. They don't see the impact. One of the problems, again, is that you can be hacked without even you knowing. I mean, they can hack the part and they can add it to a botnet. They don't see anything. It doesn't affect you. I mean, okay, you're giving out all the information that anybody wants. I mean, that information can be sold, but you don't see anything.